Hi guys, this is Sonnenberg here. We're going to be talking today about controlling acid effects and harmful emissions. It's for Science 9 students studying environmental chemistry, and this is going to be topic 3 still in your textbook. The specific outcome we're going to be touching base on today is I can explain the effects of acids and bases combining together and also their effects on other substances. So I'll start you out with a nice little joke I found. Nitrogen decided they were going to ask oxygen out on a date, and oxygen said no. So that was a good one, but I'm kind of a geek, so anyways, so using chemistry to control acid effects. So we've been talking about the process of neutralization. We also talked about the formation of acid precipitation or acid rain from the harmful emissions of natural oxides into the air. And so as that happens, what we see is we see acid rain falling down in a form of precipitate, and it causing harmful effects on the environment, especially aquatic ecosystems, as this water runs to lakes through rivers, streams and such, and runs off mountains or possibly, and it makes its way basically into these water bodies. And so that can affect several different organism species, plant and vegetation life and such, because of the low acidity. So we know that acid is typical, or rain has an acidity, a pH of about approximately 5.6 on average. And so what's happening when we see this acid rain is we're going to see this precipitation or this acid rain that falls. It's going to be between a pH of 3 and 4, which is more acidic than 5.6. Remember, the lower the number, the more acidic the substance is, or the solution. So what we do though to counter this effect, and what chemistry can do to help us, is we can use a process called neutralization. And so what we can do in the environment to control these acid effects is we can neutralize. And we just recently did a lab activity on neutralization by taking an acid and adding it to a basic solution. And so we can do the reverse process where we can add a basic solution to an acid, and what we're doing is we're seeing the formation of water, or H2O, because acids have an excess of hydrogen ions, okay, and that's an acid, and a base has an excess of hydroxide, okay, and so that's the base. So what happens is when these combine, we get HOH, which can also be written as H2O, and we get this neutralization process. So what we do is we can use this concept of neutralization and adding basic substances to acidic substances, and we can actually neutralize and create water. So what we do is when this acid precipitation or this acid rain falls, we do use a process called liming. And liming is basically, we take lime, which is in its chemical name is going to be calcium hydroxide, and hydroxide being the key here, because hydroxide is going to bond with the excess of hydrogen ion, and it's going to neutralize and create the formation of water. So the word equation is going to be calcium hydroxide plus sulfuric acid is going to react to produce calcium sulfate and water. And so what they do is they add this lime to lakes, because by adding this lime, this calcium hydroxide, they're actually going to bond and they're going to neutralize and form water and calcium sulfate, and it's going to neutralize the acidity of the lake, and it's therefore going to lower the acidity of the lake to a rate or a pH at which natural habitat in that specific aquatic ecosystem can actually survive, and it's also going to then help vegetation and such, and it's going to stop the effects on the species through the various trophic levels as they move up. Because remember, if we affect one species in the lower trophic level, it's going to affect every trophic level above that utilizes that specific species for its survival. So we use this process called liming. But in Alberta, we're kind of lucky because we have these vast structures called the Rocky Mountains. And I love going to the mountains. And you always think of the mountains as something you look at that's beautiful and something that's rare and something that's our own that a lot of the world doesn't really have. But what these Rocky Mountains actually contain is a rich deposits of limestone. And I've just written this right here. I want to draw your attention to it. And what that does is it naturally makes the water basic, because as the water falls onto the mountains, it washes away any debris, but it also binds with that rich deposit of limestone, and it's going to just naturally neutralize and create a more basic solution. So when acid rain is going to fall, it's almost neutralized immediately when it comes in contact with the mountains, and as the mountains melt, or as the water rolls and falls down due to gravity down the mountain, it's being neutralized at the time. So we have these alkaline minerals such as the calcium carbonate or calcite that's left after glaciers are melted, so like maybe following the ice age, and they basically provide a basic aquatic environment so that the acid precipitation, it's going to get neutralized almost immediately after it enters the lake and water system, because we actually find some of these this calcium carbonate that's going to make its way down into the lake beds and such, which is going to, when that acid rain meets, it's going to neutralize the solution and it's going to form H2O. So if we take a look at this equation, we get CaOH2 plus H2SO4. So this is going to be our base, this hydroxide, and then we're going to see an acid, so sulfuric acid. Okay, and so we're going to find that sulfuric acid is actually created by sulfur dioxide and the combination of water vapor or water in the air, and it's going to form as sulfuric acid in the form of acid rain precipitate. But what's happening is this hydroxide is going to bond with the hydrogen right here, and then that's what's going to create the formation of water. So this is one way that we can use chemistry to control acid effects, is by adding things such as lime. So moving on, we're going to talk about harmful emissions, because a lot of the acid rain is caused by emissions that are emitted into the atmosphere or into the air. So the concentration of chemicals in the environment can be changed using different techniques. So we have this process called dispersion, and that's basically the scattering of a substance away from its source. So one thing we can do is, from the source of maybe exhaust, what's going to happen is all those emissions are going to disperse, and they're going to spread out throughout the air. And then once they disperse, they can affect many more vegetative states. They can they can come in contact with more water and come down and create more acid rain precipitation as well, or precipitate. So another process is called dilution, if you just take a look right here. And what that's going to do is reduce the concentration of the pollutant by mixing it with large quantities of water or quantities of air or water. So, for example, a fast-flowing river or an air mass can disperse and dilute a chemical very quickly. So we can actually dilute it in that water body or in the air, and due to dispersion and the spreading out, the dilution of this, where it actually is going to mix with these water bodies or this air, is going to happen quite quickly. So what we've seen these regulations set by the governments, and so what they want to see is an acceptable level of pollutants achieved. So they want to control the amount of emissions that are set into the air to reduce the amount of acid precipitation that is occurring, but they also do this through a process which is called biodegradation. Sorry, I can spit that out. And that's another alternative or effective alternative in this process. So how do we use chemistry? Well, we use biodegradation. We understand the concepts of dispersion and dilution, and we can dilute chemicals very quickly. Okay, and so we understand these processes and we can use them to basically help the environment as well because of our knowledge in these subjects. So when we're using this chemistry or to reduce these harmful emissions, reducing emissions at a source is more economical and more effective. So trying to eliminate, say, automobile emissions, right? Majority of us have 1, 2, some of us have 3 vehicles. We have quads, we have boats, and so basically, if we can reduce the amount of emissions or the sheer volume of emissions that are emitted at the source prior to dispersion and prior to their ability to disperse and move throughout the atmosphere, if we can actually reduce these emissions and then we can also neutralize these emissions at the time, we can save the environment somewhat, even though in terms of ecological footprint, we are actually affecting it every time we drive. So the one invention they've had is called the catalytic or a catalytic converter, and basically that contains a ceramic or a wire honeycomb-like structure, and it's coated in a thin layer of metallic catalyst. And catalysts, remember from earlier in chemistry, that's going to speed up chemical reactions, and they're not going to be used up themselves. So when we talked about using hydrogen peroxide, but we talked about a natural catalyst called catalase in liver and potatoes, we actually could see the chemical reaction being sped up, but we're not using up that catalase. So this catalytic converter is going to have this catalyst in it. It's going to speed up the chemical reaction, but it's not going to use itself up, so we can continually use it over and over again for the same purpose. So the converter helps the formation of carbon dioxide gas and hydrogen or H2O gas, so it's water vapor and carbon dioxide. And it's going to reduce carbon monoxide and nitrogen dioxide. And so you can see it's going to form these two. And carbon dioxide can actually be used, plants use it for the process of photosynthesis, and then they produce oxygen. But in excess, what we get is the greenhouse effect. But what we're doing is we're reducing carbon monoxide, which is, as we know, is not, it could be potentially lethal. And then nitrogen dioxide we're going to reduce, which can form acid precipitation as it combines with water vapor in the air. It's going to form and fall in the form of acid rain. So the purposes of the converter is to encourage complete oxidation. Okay, and so if we take a look at some of these diagrams, you can see this catalytic converter with this ceramic on the inside. And what actually happens is we're going to get this carbon monoxide, this oxygen gas, nitrogen dioxide and such, and they're going to make their way through the converter. But because it has these catalysts inside, what's actually going to happen is they're going to convert and they're going to speed up the chemical reaction, and they're going to form hydrogen or water, H2O, carbon dioxide gas, and nitrogen gas. And so this is another way we use chemistry to control harmful emissions, and we control it at the source. So in a vehicle, you're actually going to find down at the base, you're going to find a catalytic converter. You'll find it in other things as well, but if I was to take the exhaust under a vehicle, okay, take the exhaust and then I have the muffler for sound, okay, and then I have a catalytic converter and then my exhaust, okay. Well, I'm taking these emissions created by the engine and then I'm actually going to convert them at this point right here so that they come out less harmful and there's less chance of forming acid precipitation. But like I said, an excess of carbon dioxide emissions is still harmful for the environment because this carbon dioxide is actually going to create what we call the greenhouse effect, and it's going to trap, and we're going to see global warming, which they say is going to affect polar ice caps, global temperatures, and such. So, but we aren't getting the vegetation loss, the soil becoming infertile, harm to species and such due to acid precipitation. So this is just one form, these catalytic converters. This is one thing we do to control at the source emissions that are lost. And we see emissions not just in vehicles, we see emissions in plants, industrial plants and such. And so what we try to do is we try to control that. And the government actually states that they want to decrease the amount of emissions that are being pressed into the environment. So they put these specifications on, and we create these technologies and such to try to help out and control the ecological footprint, control global warming, to protect species, aquatic life forms, vegetation, and other living organisms on the earth. So anyways, I hope this has helped, guys. This is basically just our way of controlling these controlling acid harms or harmful acid effects and harmful effects to emissions. Please bring your questions to me if you have any. Take notes if you can. And again, I hope this helps. So thanks for tuning in, guys. Okay, bye.